All right, we're going to look at inequalities. These are linear inequalities, and we are going to look at graphing them and determining where to shade. So the first one that I want to look at is y is greater than or equal to 3x plus 4. So we're going to start with our xy axis, and I'm going to have each graduation is a unit in each direction. And so when we look at this, the y-intercept is 4, so we're starting up here at 4. Our slope is going to be 3 over 1, and so we're going to go up 3 and over 1, and so we are going to connect the y-intercept 4 to this up 3 over 1, this slope point here. Since the inequality we see is greater than or equal to, we see that it's underlined. This is going to be a solid line. After we have the line drawn on our xy coordinate system here, the Cartesian coordinate system here, we have to determine where we should shade. Since this is an inequality, not an equal sign, there's some shading involved because there's going to be several points that when we plug the xy values in here, make this a true statement. So if our line doesn't pass through the origin, I like to use the origin because we can place zeros into both positions, the x and the y, and it makes the calculation really simple to check. If your line goes through the origin or appears to be significantly close to the origin, you can choose any point really on the axis and plug it into here and see what makes it true. We shade the true region and we will ignore the false region. So let's use the origin here. If I plug 0 in for y, I have 0 there. And that is going to be greater than or equal to what's going on over here. I'm going to plug in 0 into x also. So I have 3 times 0 plus 4. 3 times 0 is 0 plus 4 is 4. So when I simplify this, I have that 0 is greater than 4. This is a false statement. Since this is false, that means that the point at the origin is not giving us true values here. All of its neighbors will give us false values as well. And so the true region must be on the left-hand side here. So this is the region that we would shade for this line. Now, I want to look at this linear equation also, and I'm going to graph this on a separate xy axis. And now I'm going to look at the y-intercept is at 3. Again, my graduations are going to go as a unit increment. And so I'm going to start at 3, which is here, and then I'm going to go up 2 and over 1. So I have a point here and a point here. Since this is strictly greater than and not greater than or equal to indicate that in my graph, I am going to use a dotted line here. So that's the difference. Solid line for the greater than equal to, dotted line for something that is strictly greater than. And then again, I'm going to choose a test point and plug it into here. I'm going to use the origin again, plug that in. And so I'll have 0 is greater than 2 times 0 plus 3. 2 times 0 is 0 again, plus 3 is 3. So I have 0 is greater than 3. Again, this is a false statement. So the origin and all of its surrounding points are going to be false. So again, I'm shading above this line. And so half the plane is a solution for this. Half the plane is not a solution for this. Cheerful calculations.